Today, we're stepping into a pretty special kind of kitchen. See, we're not cooking food, but we are following a recipe to create one of the most amazing materials for our planet's health, biochar. So let's just kick things off with a big question. How in the world can we take something like everyday farm waste, wood scraps, leftover crops, even manure, and turn it into a high-tech sponge that literally soaks up pollution? I know, it sounds a little like magic, but I promise you it's all science.
So here's our game plan. First, we'll cover what biochar actually is. Then, we'll get into the kitchen and check out the cooking process. We're going to look at the two most important dials you can turn, temperature and time, compare the results, and then we'll talk about why this whole thing matters so much.
All right, first up, biochar, the super material. What really makes this stuff so special? Well, it's all about taking something nobody wants and turning it into an environmental powerhouse. Okay, so what is it exactly? Well, biochar is basically a super carbon-rich solid, kind of like charcoal. And the secret sauce is right there in the recipe. You take biomass, and that can be almost any organic waste, and you heat it up. But, and this is the key, in a place with no oxygen. That one little detail is what gives it all its incredible properties. And check this out. This shows you the entire beautiful life cycle. You start with waste biomass, you convert it into biochar, and then you put it right back into the soil. And it doesn't just help plants grow better, it also locks away carbon for hundreds, even thousands of years. It's this amazing closed-loop solution for farming and for the climate. So, how do we actually make it? Well, that brings us to the recipe itself. It's a special kind of no-oxygen cooking called pyrolysis. Now, pyrolysis sounds super technical, but really, it's just a fancy word for heating something without oxygen. Imagine baking something in a completely sealed-off oven. First, you heat up the biomass. Since there's no oxygen, it can't catch fire. Instead, it starts to break down, releasing gases and a liquid called bio-oil. And what's left behind? That solid carbon-packed biochar. That's the good stuff. And what's so cool is that how you cook really matters. If you do it nice and slow over several hours, you maximize your biochar yield. You get about 35% of the starting material back as biochar. But if you crank up the heat and do it super fast, in less than 30 seconds, you barely get any biochar at all. Instead, you get a ton of bio-oil. The takeaway here? We are in complete control of the outcome. And that brings us to the first big control knob in our biochar kitchen, the temperature dial. Just like baking a cake, the heat setting you choose is absolutely crucial. And here's the main idea you need to grasp. The hotter you cook it, the more you change its physical structure. Higher temperatures create way more pores and a much larger surface area. You're basically creating a microscopic labyrinth inside the material, turning it from a simple piece of charcoal into an ultra-absorbent sponge. But of course, there's always a trade-off, right? While those high temps give you that amazing spongy structure, they also increase the ash content. And maybe most importantly, they reduce your final yield. The hotter you go, the less biochar you actually get at the end. It's that classic dilemma. Do you want more of it, or do you want it to be better?
So is that trade-off worth it? Well, the data speaks for itself. This chart shows how well biochar removes ammonium, which is a really common pollutant in water, and it's no contest. The biochar that was cooked at 500 degrees Celsius consistently outperforms the 300-degree version. So if your goal is cleanup, hotter is definitely better.
But temperature isn't the only knob we can turn. There's also residence time. In other words, how long should we leave it in the oven? And the research on this is crystal clear. As this quote says, a longer residence time, a longer cook time, directly leads to a better adsorption capacity. It just gives the biomass more time to fully transform, creating a more perfect, refined internal structure. It really is that simple. A longer bake makes a better sponge. And we're not talking about a small improvement here. Look at this number. For that high-performance 500-degree biochar, just by doubling the cook time from 30 minutes to 60 minutes, its pollution-fighting power jumped by 22%. That is a huge boost in performance just from having a little extra patience.
Okay, so let's put it all together. It's time for a direct, side-by-side comparison to really see the difference our cooking methods make. It's a tale of two biochars. Here it is, plain and simple. The low-temp biochar, you get more of it, a higher yield, but it has fewer pores and it's just not as good at soaking things up. The high-temp biochar, sure, you get less of it, but it's a structural masterpiece, way more porous and a much better adsorbent.
So it all comes down to that key trade-off. Are you optimizing for quantity or for quality? And the charts really drive this home. Now don't worry about all the tiny numbers, just look at the pattern of the bars. On the chart to the left, a lower bar is better, and you can see the orange 500-degree bars are the lowest. On the chart to the right, a higher bar is better, and again, those same 500-degree bars are the tallest. The data confirms our recipe. For the best performance, you want high heat and you want to cook it for a longer time.
All of which brings us to the big finale. Why does any of this matter? Well, it's about taking this recipe out of the lab and using it to solve some serious real-world problems.
Because we can fine-tune the recipe, we can create custom-designed biochars for all sorts of different jobs. You need a super sponge to clean up a chemical spill? We can make that. You need a soil amendment that holds water and nutrients for years? We can make that too. It's a tool for cleaning our environment, improving our farms, fighting climate change, and even making cleaner energy. The list just goes on and on.
So, if you remember one thing, make it this. Biochar isn't just one single material. It's more like a versatile platform. By mastering the recipe, by carefully controlling that temperature dial and the timer, we can literally engineer a solution to some of our biggest environmental challenges, all from stuff we used to just throw away.
And that leaves us with a pretty cool thought to chew on. We now have the ability to custom design a material from waste to solve very specific problems. So the only question left is, what problems should we point this amazing technology at next?